Another example by u substitution, cosine to the fifth theta, sine theta, d theta. We're always looking for our u to be the inside function. The only thing that is inside another function is going to be the cosine. I've got cosine to the fifth. And remember what this means. This means cosine theta to the fifth, sine theta, d theta. So the cosine theta is inside that fifth power function. So I'm going to let u equal cosine theta. So that du is equal to derivative of cosine is negative sine and a d theta. All right, so I've got cosine theta, that's my u. We're glad that the sine is there. I actually need that sine, so I need a sine theta d theta. I actually need that to be a -1 times sine theta, so I'm going to put a -1 here, and I'm going to compensate for it by putting a -1 on the outside, right? So that this -1 times sine theta d theta can be my du. So my integral is -1 on the outside, integral. The negative and the sine theta d theta get pulled inside the du. So all I have left, brackets, is u to the fifth. Everything else got pulled into the du. All right, so the negative is going to go along for the ride, -1. Find the antiderivative. U to the fifth is about the easiest one we've had so far. U to the sixth over 6. Add our plus c. And now we're going to change back to our original variable. So I've got the negative u to the sixth is cosine theta to the sixth over 6 plus c. Probably easier to rewrite that with our shorthand notation for trig exponents. So negative cosine to the sixth theta over 6 plus c. Or you could write that as -1/6 times cosine to the sixth. Last one for the videos today. As always, don't worry about not knowing how this is going to turn out. You're just going to try something and see if it works. If not, we have to try something else. So we're going to let u be equal to our inside function. Again, the only thing that's inside anything is that 3 over x that's inside the sine function. So I'm going to let u equal 3 over x. We're going to take the derivative, so I need to rewrite this as 3x to the -1. So du, we're going to bring down, let's see, 3 goes along for the ride. We're going to bring down the -1. -1x to the -2, -1 minus 1 is -2, dx. And let's rewrite that without a negative exponent. We don't have any negative exponents in our integral. So I'm going to have a -3 on top over x squared dx. And all of a sudden that x squared down in the denominator, we're glad that it's there because it means that I'm actually able to do this integral. If it's helpful to you to rewrite this as the integral of sine 3 over x times 1 over x squared dx. That might make it look a little bit more like your du. That might be helpful. All right, so I need, for my du, I need a dx. I need this x squared down in the denominator, but I need it to be multiplied by -3. So that's what I want to compensate for with my green pen. So -3 on the inside, -1/3 on the outside. All right, so my -3 times 1 over x dx together are going to become my du, and the 3 over x inside is going to be my u. So let's see what we have left. I've got -1/3 integral. The -3 got pulled into the du, so I'm not going to copy that. And I've got sine of u. And all of the other junk in the integral got pulled into the du. So sine of u du. And antiderivative of sine is negative cosine. So I've got -1/3 times negative cosine. So that negative cosine is going to turn this to a positive cosine u plus c. And then we'll just plug our u back into our cosine function. So +1/3 cosine of 3 divided by x plus c. More examples to come when we get together in Zoom.